Welcome to the Deep Dive. Today we're really getting into the weeds on something important for anyone running extreme networks gear. We're looking at how management interfaces evolved in their VOSS operating system.
That's right. We've got this technical doc here, VOSS 8.2 segmented MGMD stack, and we're going to break down what it all means.
Specifically, focusing on the big shift with version 8.2.
Exactly. Understanding this change, how you talk to your switches, especially post 8.2, well, it can honestly save you a lot of headaches.
So our mission today is to unpack the challenges, the complexities before 8.2.
And then see how this segmented management stack in 8.2 aimed to make things, clearer, more robust, maybe less frustrating.
Okay, let's start right there. Before VOSS 8.2,
Okay.
how did you typically manage these switches? What were the main methods?
Well, there were basically two ways. You had out-of-band OOB management that uses a dedicated Ethernet port, keeping management traffic separate.
Okay, the dedicated management port. Makes sense.
And then there was in-band. That used any IP address configured in the main routing table, the default global routing table.
The GRT or VRF0, right?
Precisely. VRF0.
Seems straightforward enough. So where did the problem start?
The tricky part was how the switch picked which path to use. It was all based on routing. If you had your OOB network and your main network, the GRT, configured so they could route traffic between them, well, that could cause trouble.
Trouble how?
It could lead to something the documentation calls non-functional asymmetric routing.
Non-functional asymmetric routing. Okay, that definitely sounds like something that could ruin your day. Can you maybe walk us through an example? What did that look like?
Sure. Imagine you're trying to SSH into the switch using its in-band IP address, right? So the request comes in via the GRT.
Standard enough.
But if the switch also had an OOB IP configured, and importantly, if there was a valid route back to your management station through that OOB path, the switch might decide to send the SSH reply back out through the OOB port. Ah, okay. So request in one door, reply tries to go out a different one.
Exactly. And for protocols that need a stable connection, like TCP.
Like SSH, Telnet.
Right, SSH, Telnet. Even SNMP sometimes uses TCP. That mismatch just breaks the connection. It fails.
Because the return path is unexpected.
Precisely. And what made it super confusing was that a simple ping using ICMP, that might still work fine because it's connectionless.
So you could ping it, think it's fine, but you couldn't actually manage it.
Yeah, exactly. It made troubleshooting a real pain. Fundamentally, pre-8.2, management could feel a bit unpredictable sometimes. 8.2 really aimed to fix that predictability.
That intermittent stuff is the worst. The document also mentions some ambiguity around source IPs for traffic the switch initiates, like radius or SNMP traps.
Yeah, that was another complexity. Yeah. When the switch itself sent out traffic, say an SNMP trap or a radius request, the source IP it used wasn't always obvious. It might pick the nearest IP on the GRT or maybe even the ISIS source IP if that was configured. So you couldn't easily predict which IP address your radius server or NMS would see.
Pretty much, which often meant you had to manually configure a specific source IP for those protocols on the switch just to ensure things worked reliably.
More manual work, less flexibility. And it sounds like some older switches didn't even have that dedicated OOB port option.
That's correct. Models like the XA1400, VSP4850, VSP4450, they just didn't have a physical OOB port. And the 4850, it's worth noting, only ran older VOSS versions anyway.
Okay, the document has this diagram showing the asymmetric routing problem. Let's visualize that. OB segment, management segment, router, firewall. How did the traffic flow cause the break?
Right. So imagine your management request starts on your management network, goes through the firewall, hits the switch's in-band IP in the GRT.
Okay.
Now, if the switch has that OOB IP and there's a route from the OOB network back through the router, maybe through the firewall again, to your management station, the switch sees that route and thinks, hey, I can send the reply this way. So the reply goes out the OOB port.
But the firewall, especially if it's stateful, is expecting the reply to come back, matching the initial inbound flow.
Exactly. Different path, maybe different firewall rules, the state doesn't match, and boom, connection fails.
So the recommendation back then was just keep OOB totally separate. Don't let them route to each other.
Precisely. Keep the OOB network isolated. And crucially, don't put a default route in the MGMT router VRF, which is VRF 512. The whole idea was to stop the switch from accidentally routing in-band responses out the OOB interface.
Okay, so VOSS 8.2 comes along to fix this. Did it solve the asymmetric routing problem completely?
Mostly, but not entirely. It fixed the issue for TCP-based management requests, the things you initiate, like SSH or Telnet.
So interactive sessions became reliable.
Yes, But the document clarifies the potential for asymmetry could still exist for UDP-based protocols, and think SNMP queries, radius authentication, syslog messages.
Ah, okay. UDP is connectionless, so maybe less noticeable, but still potentially problematic.
Right. And it could also still happen for any traffic, TCP or UDP, that the switch initiates itself, like sending traps or logs.
Got it. So a big improvement for interactive management, but some edge cases remain. This brings us neatly to segmented management itself in VOSS 8.2. What was the core change?
The fundamental shift was introducing 3 distinct, unambiguous IP management interfaces.
Unambiguous. I like the sound of that.
Yeah. They are MGMT OOB, MGMT CLIP, and MGMT VLAN. It's moving away from that sort of blended approach to clearly defined management path.
Okay, MGMT OOB is pretty obvious. That's for the physical out-of-band port, if the switch has one.
Correct.
What about MGMT CLIP and MGMT VLAN?
So MGMT CLIP stands for circuitless IP. The key thing here is you can tie it to any VRF, including the GRT. Big flexibility boost there for logical segmentation based on your routing.
Okay, so COP isn't tied to a physical wire. It's a logical interface associated with a routing instance.
Exactly. And then MGMT VLAN, like the name suggests, lets you assign a dedicated management IP directly to a specific VLAN on the switch.
Which sounds great for segmenting management based on your layer 2 topology.
Yeah.
What's the main benefit of having these separate types?
The single biggest improvement is how replies are handled. With segmented management, when a request comes in on, say, MGMT CLIP, the reply always goes back out using that same MGMT CLIP interface. Same for MGMT OOB and MGMT VLAN.
Ah, so no more guessing which door the reply will use.
Precisely. It completely eliminates that asymmetric routing problem for administrator-initiated sessions. That is a huge win for predictability, for stability.
Absolutely. Consistent paths make troubleshooting so much easier.
Did this also simplify things with those switch-initiated source IPs we talked about?
It did for the responses. You no longer needed to manually configure a source IP for responses to management requests. The system just knows to use the IP of the interface the request came in on.
Okay. What about things like LLDP or SONMP, the discovery protocols? How do they fit in?
For those, VOSS 8.2 lets you choose which of the 3 management interfaces, OOB, CLIP, or VLAN, you want to use for advertising the switch's information. Gives you more control over discovery. And that old MGMT router VRF 512, is that gone now?
Essentially, yes. With this new segmented architecture, it becomes obsolete. Management is tied directly to these explicit MGMT interfaces now.
Good to know. And it's reassuring that they kept the CLI show commands and SNMP MIDs updated to reflect these new interfaces.
Yeah.
Consistency helps during transitions.
Definitely.
You mentioned some older models lack the OOB port XA1400 VSP4450. That's still true in 8.2.
Yes, unfortunately. Those specific platforms still don't have the physical OOB port. But good news on the protocol front. IPv6 is supported on these new management interfaces.
Oh, nice.
Well, except on the older XA1400 platform, no IPv6 support there.
Okay. There's also mention of a forced topology of command. What's that for?
Right. That command lets you explicitly tell the switch which management IP to use in its LLDP advertisements, especially if you happen to have multiple management IPs configured.
So you can control exactly what IP gets advertised for discovery.
Exactly. And if you have both IPv4 and IPv6 configured on the chosen management interface, it'll advertise both.
Okay, useful for controlling topology information. Let's shift to practical configuration. What are some of the gotchas or things to watch out for when setting this up in 8.2?
Yeah, there are a few important ones. First, if a switch boots completely fresh, like zero-touch factory default, it automatically creates a MGMT VLAN on VLAN 4048. Good to know that exists by default.
Right, so you don't get surprised by it.
Also, just putting an IP address on an MGMT interface doesn't turn it on. You have to explicitly go into the interface config and type enable.
Simple, but easy to forget.
And this one's crucial. Configuring a static MGMT IP doesn't automatically disable the DHCP client for management.
Ah.
So if you want a static IP, you absolutely must remember to run no MGMT DHCP client. Otherwise, it might still try to grab a DHCP address, which could cause conflicts or confusion.
Definitely sounds like the kind of default behavior that could trip you up if you weren't expecting it. What about the quick config MGMT utility mentioned?
It's a little interactive script built in. It helps with the very basic initial setup of a management IP.
Like a wizard.
Sort of, yeah, but it's limited. Only does IPv4 only one interface at a time, and it doesn't support configuring MGMT clip at all.
So handy for a quick IPv4 setup on OB or VLAN, maybe, but not for complex configs.
Exactly. It's a starting point.
You mentioned the DHCP client. Is there something new about DHCP specifically for these management interfaces?
Yes, there's a new DHCP client logic specifically for MGMT VLAN and MGMT OOB. It's mainly used in the newer zero-touch provisioning modes in 8.2 and 8.3. This involves a special private VLAN, 4048, and an eTree ISID. It's part of a more automated onboarding process. The client tries OB, then VLAN 4048, looking for a DHCP server.
Okay, so part of the newer ZTP strategy, different from the old factory defaults.
Right, different from the old boot config flag factory defaults way.
Now, what if you've got a management IP set up and you need to change it? Change the IP, change the VLAN it's on. Is that disruptive?
Well, it could be, but VOSS 8.5 introduced a command called convert to help with this.
MGMT convert.
Yeah, MGMT convert. It lets you migrate an existing MGMT IP to a different IP, or move it to a different VLAN ISID, or even associate it with a different VRF.
Okay, that sounds useful.
But the really valuable part is the built-in safety net. It has an automatic rollback.
Okay.
If you make the change using MGMT convert and you lose connectivity, maybe you type the wrong IP or VLAN, the switch will automatically revert back to the old working configuration after a timeout period.
That's fantastic. Reduces the risk during maintenance.
Huge safety feature. But you have to remember, once you make the change and confirm you can connect with the new settings, you must issue MGMT convert commit to make it permanent. Otherwise, it'll eventually roll back even if it's working.
Right. Commit the change once you know it's good. That rollback sounds like a real lifesaver. Okay, let's circle back to that asymmetrical routing issue. We know 8.2 fixes it for TCP requests. What about UDP traffic, or traffic the switch initiates?
Right. As we mentioned, the potential for asymmetry still exists there. So for switch-initiated TCP UDP messages, think SNMP traps, syslog, radius accounting, and all purely UDP-based protocols. The switch still looks at the routes available via all configured management interfaces.
So it might still pick an unexpected path for those.
It could, yes. It inspects the routes associated with MGMT OOB, MGMT VLAN, and the VRF associated with MGMT clip, and it chooses the path based on the best route, meaning the lowest metric.
Okay, and do these different management interface types have default metrics?
They do. By default, MGMT clip routes, inherited from its VRF GRT, have a weight of 100. MilGMT VLAN has a weight of 200, and MGMT OOB has a weight of 300.
So CLIP is preferred, then VLAN, then OOB by default if routes exist via all three.
Correct, assuming all else is equal regarding the specific routes.
And can we influence this? Can we add static routes or change metrics for management traffic?
Yes, you can add static routes specifically for MGMT VLAN and MGMT OOB, and you can assign custom metric weights to those static routes.
But not for MGMT clip.
No, MGMT clip just uses the routes already existing in its associated VRF, or the GRT. You manage those rights as normal within the VRF GRT configuration. Its effective weight remains 100 from the management perspective.
Got it. That's important for designing how things like syslog or radius traffic will flow. Now, the document gives specific best practices based on the switch's role. Let's talk L3 BABEs, border edge bridges, or just regular non-fabric IP routers. What's the recommendation?
For layer 3 devices like that, the strong recommendation is to use MGMT clip for your in-band management.
MGMT clip. And it suggests avoiding MGMT VLAN on L3 devices.
Yes, generally avoid MGMT VLAN for standard management on L3 routers or BABEs. The beauty of MGMT clip here is its flexibility. You can tie it to the GRT, which is similar to how you might have managed it before 8.2.
Like the old in-band MGMT.
Kind of, yes, but you can also associate MGMT clip with any other VRF you have configured, which is really powerful for segmentation. Managing L3 devices via GRT CLIP was arguably best practice even before 8.2 formally introduced MGMT clip.
Okay, so CLLP is king for L3 management. What about L2 BEs or standard non-fabric L2 switches?
For layer 2 devices, the recommendation flips. Use LMBMT VLAN for in-band management.
Makes sense. Tying it to a VLAN.
Right. You could technically use MGMT clip on an L2 BB, but it usually requires enabling SMIP features, which you might not want or need on a purely L2 edge device.
And on a non-fabric L2 switch, CLIP doesn't make much sense without L3 interfaces anyway.
Exactly. With MGMT VLAN on an L2 switch, you associate it with a platform VLAN, And that VLAN can even be part of a larger fabric service, an L2 VSN, if you assign an ISID.
But there's a catch with MGMT VLAN, right? Something about SES-flow.
Yes, good point. Application telemetry, which often uses S-flow, currently doesn't work if your management IP is an MGMT VLAN.
So if you need S-flow or similar telemetry.
You'd have to use MGMT clip, even on an L2 device, maybe making it L3 aware, or potentially MGMT OOB. That's a key limitation to remember for MGMT VLAN.
Okay, good distinction. Now, DVR leaves, distributed virtual routing leaves. They're kind of hybrid L3 in the data plane, but maybe managed more like L2.
Yeah, they're a special case. The guidance depends on how you want to manage them. If you manage a DVR leaf over the GRT, use MGMT clip. This directly replaces the old in-band MGMT IP concept for DVR leafs. And importantly, on a DVR leaf, MGMT clip can only be associated with the GRT.
Only GRT for MGMT clip on DVR leafs.
Yeah.
Okay. What if I want to manage it over a specific VRF?
Then you'd use MGMT VLAN. You create the MGMT VLAN interface associated with your management VRF. There's a specific setup involved. You typically also have a regular platform VLAN with the same V, assign an ISID to it, and your DVR controllers need a VREIP in that same VRF and ISID to provide the gateway.
So the loop reaches its gateway on the controller via the fabric using that ISID and VRF.
Exactly. The doc advises not putting DVR routing directly on the management VLAN itself. It relies on routing via the controllers. This MGMT VLAN approach could also work for GRT management on a DVR leaf, by the way. And of course, MGMT OOB is always an option too.
Right. Sounds like DVR leaf management requires careful planning based on GRT versus VRF approach. Are there other, maybe less common scenarios where you might need MGMT VLAN even on an L3 BEB?
Yes, a couple of niche cases are mentioned. One is Fabric Extend, maybe over an XA1400 or VSP, using a dedicated VRF for the transport. If you need to manage that switch via that Fabric Extend VRF from outside, like for Cloud IQ or over a WAN, MGMT VLAN might be the way.
Okay, managing through the transport VRF itself.
Another example is if you have a VSP 7400 or 4900 running a Fabric Interconnect Gateway VM, the FIGW VM. If you need to SSH or FTP to that VM from the host VST switch, you might need an MGMT VLAN configured.
Specific inter-device communication needs.
Right, and in both these cases, the document notes you'd likely also have a MGME clip for regular management, and there's a strict rule. If you create a MGMT VLAN on a VLAN that already has a regular GRT or VRF IP interface,
Yes.
the MGMT VLAN IP address must be the exact same IP as the existing interface IP on that VLAN.
To prevent conflicts on the same broadcast domain. Makes sense. Okay, thinking about L3 BEVs again, what's a common mistake people make with segmented management here? A pitfall to avoid.
The big one highlighted is trying to use a GRT VLAN IP for managing an L3 BEB after you've enabled segmented management.
So configuring a regular interface VLAN X with an IP and trying to manage the L3 switch via that IP.
Yes, specifically using MED VLAN tied to that GRT VLAN. The problem is that MEMT VLAN IP is only reachable if the management traffic physically arrives on that specific VLAN.
Even if you have routing set up correctly within the GRT.
Even then, if your SSH request comes in on a different interface within the same GRT, the switch will not route it internally over to the MG VLAN IP, even if a route exists in the GRT routing table.
Wow, okay. That's subtle but critical.
Absolutely. That's why the guidance is so strong. For L3 routers and L3 EVBs, use MGMT clip for in-band management. It avoids this whole issue.
MGMT clip for L3. Got it. Let's talk upgrades. Someone's on VOSS 7 or early 8.0, planning to move to 8.2 or later. How do they handle migrating their management config?
There's a key command, migrate to MGMT. It was actually introduced back in 7.1.3, 8.0.1, 8.1.0 to help prepare for this.
So you run this before the upgrade?
Ideally, yes. For L3 devices, after you upgrade, any old GRT CLP you had configured is just gone.
Okay.
And if you are using an ISIS source IP tied to that old CLP, you need to create a new GRT CLP, crucially, with a different IP address, and then reassign the ISIS source IP to that new CLP after the upgrade.
Can you prepare that beforehand?
Yes, the doc suggests a pre-upgrade strategy. Create a second temporary CLP, move your ISIS source IP config to point to that temporary CLP, then run migrate to MGMT on your original management CLP. That way, ISIS keeps working during the upgrade using the temp CLP.
Clever, and ISIS source IP is still relevant in 8.2.
It's recommended for things like IP shortcuts and apparently will be needed again for DVR1 IP, so yeah, still important in many designs.
Okay. What about migrating L2 devices?
For L2 switches, or L2 BEBs, after the upgrade, any old GRT VLAN IP used for management will be gone. The main caution here is, if your switch had multiple IPs on multiple VLANs before the upgrade, stop and think. It was probably acting as an L3 device, and you should really be migrating it to use MDMT clip instead of MDMT VLAN.
Good point. Don't just assume L2 if it had multiple IPs.
And remember the SES flow limitation. If you need application telemetry on that L2 device, you can't use MGMT VLAN. You'll need to plan for MDMT clip or MGMT OOB instead.
Right. What about those DVR leaves? Is their migration easier?
Generally, yes. For DVR leafs, if they were using the old in-band MGMT IP command, you just upgrade. That configuration automatically converts into the new MGMT clip associated with the GRT.
Nice and simple.
And the old ISIS in-band MGMT command just becomes obsolete.
The document includes a summary table for different upgrade paths, right? Covering OB managed, DVR leaves, SBB managed, L3 VLAN managed, L3 clip managed, etc.
Exactly. It's a really handy table. It lists the pre-migration steps, like using migrate to MGMT, and the post-migration checks or configurations needed for each scenario. Definitely worth consulting that before you upgrade.
Okay, crucial question then. What happens if you don't run migrate to MGMT before upgrading, in scenarios where it was recommended?
Uh-oh. Yeah, that can lead to problems. In most cases where you relied on in-band management, COP, VLAN, IP, IPSC, if you upgrade without running migrate to MGMT first, and you don't run commit software after the upgrade, you will likely lose your in-band management access after the switch reboots on the new code.
Ouch. Locked out, potentially.
Potentially locked out of in-band access, yes. You might only be able to get in via the OB port if you have one configured and accessible, or you might have to roll back the software version to regain access and then try the migration properly.
So that migrate to MGMT command sounds pretty darn important for a smooth upgrade if you're using in-band management.
Very important. Plan ahead.
Okay, one last area. Ping and traceroute. Anything change with those familiar tools in 8.2?
Yes, a small but significant change in behavior when you run them from the VSP switch itself. In 8.2 and later, if you want the ping or traceroute to originate from one of your new MGMT interfaces, OOB, clip, or VLAN, you must specify the context.
How do you do that?
You add MGMT at the end of the command. So ping IP address MGMT or traceroute IP address MGMT.
And if you don't add MGMT?
It defaults to using the GRT as the source, just like it always did. You can also explicitly specify GRINT or VRF name if you want to be sure.
Is there a way to change that default?
Yes, there's a new command sys default ping context. You can set the default to either GRET or MGMT for pings where you don't specify a context.
Okay, good to know. You need to be explicit if you want to test connectivity from the management plane itself. Well, this has been quite the journey through VOSS management interfaces.
It really has. We went from the sometimes confusing world before 8.2 with those asymmetric routing risks.
Right, the potential for connections just dropping unexpectedly.
To this much more structured, segmented approach in 8.2 and later.
And the benefits seem clear. Better separation, much more predictable behavior for management requests, more flexibility with C-clip and VLAN options.
Definitely clear. But, as we saw, still need to be careful with UDP, switch-initiated traffic, and choosing the right interface type CLFP for L3, VLAN for L2, mindful of those exceptions like S-flow and DVR leafs.
Absolutely. So it brings us to a final thought for you, the listener, to consider. Now that VOSS offers these distinct segmented management interfaces, OOB, clip, VLAN, how could you leverage this granularity in your own network? Beyond just basic connectivity, could these separate paths enhance security? Maybe allow for more refined access control policies? What new strategies for segmentation or operational workflows do these options open up for your VOSS environment?
It's definitely something worth thinking about, how to take full advantage of this more structured management plane.
Indeed. Thanks for diving deep with us today.